So thus far, we've looked at the probability of survival past any time t with the survival function, and we've looked at the immediate risk of death if a patient makes it to time t, and that's the hazard. We'll now look at another question, which is what is the patient's accumulated hazard or accumulated risk up to time t? And we're going to represent this with the Greek letter capital lambda. Remember, hazard is small lambda. This is going to be capital lambda of t. And of course, a patient's accumulated hazard up to time t is very related to their hazard at time t. And the relationship we can write in the following way. So we have capital lambda of t, and let's select t to be 3 right now. So we have capital lambda of 3, which is going to be our hazard at time, all times up to 3. So we have our hazard at 0, plus our hazard at 1, plus our hazard at 2, plus our hazard at 3. And so we're summing up all time steps up till time 3 over here, but the general formulation of this up to time t is going to be a sum from I equals 0 to t of small lambda of I. So this is saying for any time t, I'm looking at all time points before up to that time t and summing them up. So this is the expression that we get when the time can take on discrete values like 0, 1, 2, 3. We've also seen where time can take on any continuous number between 0 up to 3 or whatever amount we want. And so for that, we have the continuous extension of the cumulative hazard, which we write down as the integral from 0 to t of lambda, we're just going to call this I, di. And don't worry too much about this. All that you need to understand is the cumulative hazard is going to be the sum, and this is just a way to represent the sum when our time is continuous. And so we've seen earlier a hazard curve that tells us the instantaneous risk on the y-axis and with the time on the x-axis, and we can use this hazard curve to tell us what the corresponding cumulative hazard curve is going to look like using the formula that we saw earlier. And once again, don't worry too much about what this formula is doing if you haven't seen integrals before. It's just a way of summing up the hazards along the time axis. And so this is the corresponding cumulative hazard that tells us how the patient's accumulated risk over time is changing. This is a constant hazard curve, so we can see that over time the hazard isn't changing, and the corresponding cumulative hazard curve for this looks like the following. So you can see the straight line going up as we're summing over the time dimension over here. And so previously we've seen that survival models can be used to output a survival function. But now we know that it can not only be used to output a survival function, but also a hazard function or cumulative hazard function. And we can use any one of these to derive the others by using some formulas that allow us to represent that function in whatever way is most appropriate for whatever question